Hey A&Pers, this is Dr. Jones checking in. This is A&P 2 lecture test 4, video number, I think 5. And we're starting towards the bottom of Noteset page 8. We're at, I think, the chart. But let's do a quick review. So I want to make sure everyone understands that when the diaphragm contracts, it pulls down because you see the length of the muscle, and anytime a muscle contracts, it gets shorter. So when the diaphragm contracts, it gets shorter, and that because of the fluid bond between the visceral and parietal pleura, when the diaphragm contracts and the ribs expand up and out, the volume inside the lungs gets bigger. And the volume gets bigger, that means that the pressure goes down. And air moves from areas of high pressure to areas of low pressure. So when the diaphragm contracts and the ribs expand, that increases the volume, which decreases the pressure, and air moves from areas, I need a pen, sorry, pen color, I'm gonna go with red. So when the diaphragm moves down and the ribs move up and out, that increases volume, which decreases pressure, and air moves in. Now, I guess we could do the next one in a different color. Magenta? No, that's too close to red. Let's do neon green. Okay, since it's the opposite. So to exhale, the diaphragm relaxes and goes back to where it was in just normal breathing. And the ribs relax and go back to where they were. So that decreases the volume, which increases the pressure. And now we've created an area of high pressure, and air moves from areas of high pressure to areas of low pressure. Okay. So, basic concept review. Also, this picture is on the test. So, when the pressure outside equals the pressure inside, there is no air movement because air only moves when you squish it. From areas of high pressure to areas of low pressure. And then here you see when pressure outside is greater than pressure inside. So how do you make the pressure outside greater than the pressure inside? How do you lower the pressure inside? You increase the volume. How do you increase the volume? You contract the diaphragm, you contract the external intercostals, your ribs expand, your diaphragm drops, you've made an area of low pressure, and the air sucks in. So you can even try this, like put your hands on your rib cage and like expand your rib cage, and the air just goes in because you expanded your rib cage. And then like compress your rib cage. You push the air out, which is the next picture. So in the next picture, pressure outside is less than the pressure inside. So how do we increase the inside pressure? We decrease the volume. How do we decrease the volume? We stop contracting the diaphragm and let it go back to its resting position. And we stop contracting the external intercostals and let the ribs go back to their normal position. So in quiet breathing, which we're about to talk about, inhalation is active because you're contracting muscles and burning ATP, but exhalation is passive because you're just stopping the contractions, and it does not require ATP to exhale on a calm breath, a normal breath, eupnea. Okay, so eupnea is your normal breath, hyperpnea is your other. I'm going to move me out of the way. There you go. Sort of in frame. There we go. So the hyperpnea is the forced breathing. So inhalation. I'm recording. So inhalation is quiet and active. Okay, eupnea is quiet breathing. So inhalation is active and exhalation is passive, as we just said. And to do this, you contract the primary respiratory muscles. Those are also called the primary muscles of inspiration. I'm going to put me on screen while here. And that includes the diaphragm, which is 75%. And the external intercostals are the other 25%. So those are the two primary muscles of inspiration, or the primary respiratory muscles, same difference. And so for exhalation in eupnea, you relax the primary muscles and the elastic rebound. As you'll see in lab, there are lots of elastic fibers in the lungs, and you stretch them out when you inhale, and then when you stop inhaling, they bounce back. Okay. And now we have the hyperpnea. Move me off screen here. Okay. Hi. Okay, so hyperpnea is forced breathing. I had some sort of color coding on the previous screen, which I no longer have. I apologize. Inhalation is active and exhalation is also active. So this is forced breathing. This is when you take a big, deep breath, like the doctor told you to take a big, deep breath. So you will contract the primary muscles of respiration, which are the diaphragm at 75% and the external intercostals at 25%. And you will also contract the accessory muscles of inhalation. And the accessory muscles of inhalation include the sternocleidomastoid, which is this muscle right here in the neck. It helps lift the rib cage. The serratus anterior, recall those, they land on the ribs, one on each rib, and they help expand the rib cage. And the pectoralis minor, which is that one that was just deep to the pectoralis major, and the scalenes we didn't learn in lab, so we'll glance over that. And then exhalation is forced active. And so exhalation, okay, I'm going to move me back. Okay. So exhalation is in hyperpnea is forced and active. So this is blowing out the candles on the birthday cake. Incidentally, they did a study a few years ago about the bacterial load on the surface of a cake before and after someone blew out the candles. And it was terrifying. So if I could recommend blowing out the birthday candle on your own personal cupcake and not blowing your germs on everyone else's food, that would be great, because it's one of those things like, oh, it's perfectly harmless, until you actually like look at the numbers and like, oh, that's disgusting. Like bobbing for apples. When I was in grade school, we actually did that at school for like our fall festival, because, you know, for Halloween. And we actually like all put our faces in the water trying to get our teeth on the apples in the water, and and it's, oh my criminy, this actually happened. And now it's like, that's the most disgusting thing I've ever heard. It's the same thing with blowing out the candles on the birthday cake. It doesn't seem like a big thing, but once you've seen the numbers about the increase of the bacterial load, no, that's never happening again. Thanks. Good to know. So to blow out the candle on your personal birthday cupcake, you both relax the primary muscles of inhalation and the accessory muscles of exhalation, which are all these that we talked about. The diaphragm, the external intercostals, the sternocleidomastoid, serratus anterior, pec minor, and again, we never learned scalene. So, but you also contract the accessory muscles of exhalation. Now, to be clear, there are no primary muscles of exhalation. This is just the accessory muscles of exhalation. So this helps you blow out the candles on a birthday cake. Which again, this is COVID times, so it's just a stupid idea anyway. So first we have the internal intercostals. Remember, these are the external intercostals up here. And now we have the internal intercostals. The transverse thoracic we never learned. The obliques, the internal and external obliques, and then all the rectus abdominis and the transverse abdominis. And the dog is barking at me, which means the children have gone outside. Okay. So now let's turn to page 9 and continue filling in the note set. Oh, and here's the picture of the primary muscles of inspiration, the accessory muscles of inspiration. I think I may have taken off the scalenes. Scalenes aren't even on that picture. Let me move me. There we go. External intercostals, internal intercostals, external oblique, rectus abdominis, internal oblique, and also transversus abdominis. Okay. Eupnea. There we go. No, not yet. Okay, going back then. Eupnea is quiet breathing. You contract the muscles to inhale, relax to exhale. There's two different types. There's diaphragmatic, which is deep breathing. If you take the, like you're singing and you take a deep breath and you sing with your gut, you're like, okay, like that. And then there's costal breathing. Costal, not coastal, so not nice sea air, but like ribs. Costal breathing is shallow breathing. And elastic rebound, you have a passive exhalation in eupnea because the elastic fibers recoil, and in hyperopnea, forced breathing, active inspiration and active exhalation, meaning that this also burns ATP. Eupnea has a passive exhalation, so does not burn ATP, like that. And then these muscles you're responsible for because I told you about them. You're welcome. And I don't believe this table is still in the book, but I find it interesting, so we're going to cover it because it takes about 10 seconds. So 1 atmosphere of air is the pressure of the air pushing down on you at sea level, which is where we are. And 1 atmosphere is measured at 760 millimeters mercury. Now, the respiratory therapists use torr, which is the European/scientific number, but it's the same as the millimeters mercury. It's the same number, it's just torr. So, and millimeters mercury you can also measure it as centimeters water, which they sometimes do. So there's that. And then, of course, we're all familiar with pounds per square inch, and an atmosphere is roughly 15-ish. Okay. So atmospheric pressure is the pressure outside the body. Intrapulmonary or intraalveolar pressure is the pressure inside the lungs, or more specifically inside the alveoli if it's intraalveolar pressure. And remember, there's a difference between inter and intra. I don't remember us having this conversation yet this semester, so let's have this conversation now. Inter is in between two things, like the interstate takes you from Texas to Oklahoma. The intra-state highways are just in Texas, and they don't take you out of Texas. Although you can drive for like a day and still be in Texas. So intramural sports are what you played in grade school when you played other kids inside the same school, because it was inside one. And then in junior high and high school, undergrad, you played intramural sports, where your team played the teams of other schools. So there you go. That was my one sports reference for the semester. here. Oh, also the difference between the internet and the intranet. So the internet takes you to other places. The intranet is just like an Ethernet, is an intranet. Okay, so next. You are now responsible for inter versus intra because I remember to tell you about it. See, college educated. Okay, relaxed quiet breathing. On inhalation, your lungs expand. And the intrapulmonary pressure. All right, so let's look at this chart. I'm just in the way today. Okay, so there we go. Intrapulmonary pressure is this red line. And the okay, we're not ready for that. The intrapulmonary pressure is this red line, and this 0 here is 1 atmosphere, 1 atm. So when you inhale, you increase the volume and decrease the pressure, and here is the measure of that pressure. So you go down to 759 millimeters mercury, which we will write as -1 millimeters mercury. This is one. Okay, so back to the note set. Your lungs expand, the intrapulmonary pressure drops to 759 millimeters mercury. This is 1 millimeter mercury atmospheric pressure below atmospheric pressure at -1 millimeters mercury, and causing air to move into the lungs, inhalation. On exhalation, your lungs recoil and you get to 761 millimeters mercury. This is 1 millimeter mercury, above atmospheric pressure, plus 1 millimeters mercury, causing air to move out of the lungs. Exhale. Forced heavy breathing, what's different? The pressures up to -30 millimeters mercury on inhalation, up to plus 100 millimeters mercury on exhalation. Why are you told to exhale while lifting weights instead of holding your breath? You can rupture the alveoli or even cause hernias that are very painful. And so that's why anytime you're pushing, so if you're lifting weights or you're pooping or you're giving birth, you need to be exhaling while you're pushing. Okay, you don't hold your breath while you're pushing. You're going to actually raise the intrathecal pressure so high that you can get petechial hemorrhaging and the sclera of the eye. So don't do that. I'm still way down here. Going back up. Okay, there we go. Okay, I'm guessing the next slide has the picture for intrapleural pressure. Here we go. So intrapleural pressure, bottom of page 9 on the note set. If intrapulmonary pressure is the pressure inside the lungs, then the intrapleural pressure must be the pressure, capital P is pressure, inside the pleural cavity. And the pleural cavity is the space between the visceral pleura and the parietal pleura. So if you're wanting to sample the pleural fluid, down here's a good place to do it because you're between the ribs, you're above the diaphragm, but you're not risking the lungs. Okay. And the average pressure here, which is here between peak and trough, top and bottom here, is -4 millimeters mercury. So intrapulmonary pressure, which is our red line, so our red line, the intrapulmonary pressure is, here's atmospheric pressure at 0. So intrapulmonary pressure is sometimes lower and sometimes higher. It's lower when you're inhaling. It's lower to make you inhale and higher to make you exhale. So it's sometimes lower than atmospheric pressure. Intrapleural pressure, which is our blue line, and up here is our atmospheric pressure, is always lower than atmospheric pressure. And then here's our intrapleural pressure, the blue line, is what lower than intrapulmonary pressure, the red line. Always, always. Here it's 1, 2, 3. Here it's 1, 2, 3. 1, 2, 3, 4. Here it's 1, 2, 3, almost. Anyway, it's ish, but it's ish around 4, -4 millimeters mercury lower than the intrapulmonary pressure, but it's always lower. Basic concept. What causes the low intrapleural pressure? And that's the recoil of the elastic fibers of the lungs. The lungs are vacuum stuck up to this edge because of the fluid bond of the pleural fluid. But this is filled with elastic fibers, and the elastic fibers on the model in lab are black. So all these elastic fibers, and then they pull. And that constant pull away from the edge causes that negative intrapleural pressure, which keeps your lungs inflated. It keeps your lungs stuck to the inside of the body wall. What are some of the muscles on that would be touching the parietal pleura? We've got internal intercostals, the diaphragm, of course, but what towards the front? What are the inner abdominal muscles? I wonder if that would be a good test question. That'd be a good final question. Okay. Sometimes in class I have to say that a third time for people to write it down. Okay, what happens if you lose your negative intrapleural pressure? Then you have a pneumothorax, where you have air in the pleural cavity. And then atelectasis is when you have a collapsed lung. Next page. I didn't start a timer. Yeah, I'm gonna keep going. Okay, top of page 10. You move air into and out of the respiratory system by changing the volume of the lungs. Tidal volume is the amount of air moved in one respiratory cycle. The respiratory cycle is one inhalation and one exhalation. When the intrapulmonary and atmospheric pressures are equal, you get no movement, as we have said. On inhalation, the thoracic cavity increases in volume. See, here's the picture of the tidal volume. So here's at the end of inhalation is the most air you'll have, and then tidal volume is this difference. Tidal volume. Wait, there's a letter abbreviation for tidal volume, and it's not TV, it's VT. Tidal volume. Excuse me. On inhalation, the thoracic cavity increases in volume, making the intrapleural pressure fall, and intrapulmonary pressure, intrapleural pressure falls, intrapulmonary pressure falls to -1 millimeters mercury, forcing air into the lungs. On exhalation, the thoracic cavity decreases in volume, forcing the intrapleural pressure rise, makes the intrapulmonary pressure rise to +1 millimeters mercury, forcing air out. Now let's finish this page. Okay, so resistance. I have a headache. I don't know how many videos I can do, but I'm gonna keep going as long as I can. So the resistance is to hold back, or you have friction and drag. Resist is when you resist. Like, don't resist rest. Compliance is how easily the lungs expand. Okay. And the lower the compliance, the greater the force required to fill the lungs. The greater the compliance, the easier it is to fill the lungs. Factors affecting compliance. Lung connective tissue. If you have emphysema, you have increased compliance, which seems weird because with emphysema, you're getting less oxygen. But what happens with emphysema is that the alveolar walls break down. And so you have decreased exchange surface. You have increased compliance because it's real easy to get air into the lungs because there's more air than tissue. But you have less exchange surface, way less, so you get less oxygen into the bloodstream, even though you have increased compliance. Surfactant, we talked about. Respiratory distress syndrome is a decrease in surfactant, which makes a decrease in compliance. And the mobility of the rib cage. Arthritis, severe scoliosis, decrease compliance. So with scoliosis, once the angle gets to a certain degree, scoliosis is when the spine curves to the side. Kyphosis is when the spine bends forward. Lordosis is when it bends back awkwardly, but scoliosis is to the side. So the problem with scoliosis is not the scoliosis itself, it's the decrease in rib mobility. Because studies have found that people with severe scoliosis have shorter lifespans by an average of 5 years. Because the side that gets compressed you can't expand fully to get all the oxygen into your lungs, that takes years off your life. So that whole thing in yoga, we're like, we're going to do an anti-aging exercise. And then they make you like take a deep breath. They're totally spot on. That's exactly how that works. Crazy, right? Just because it's woo doesn't mean it's not science. Some of the woo is like they've taken the science and they use it. And some of the woo is just woo. So you have to be careful with the woo, but don't discount all the woo just because the woo people use it. There is still good science in there. And a regular habit of nice deep breaths is good for you. It gets more oxygen into your lungs, more oxygen to your bloodstream, and yoga is good for you. Okay. Oh, so that's why in scoliosis, now once you get past a certain degree, they will, because surgery is always a risk and should always be the last option. But once you get past a certain degree, you're losing life expectancy. And so they will risk the surgery, cut open and like put in a metal rod and take the spinuses out, put in a metal rod. And then sometimes they'll put like a whole solid thing of like bone back over it. X-rays are trippy because there's no like spinous process. So fun. Okay, so pulmonary ventilation, compliance, and energy demands. At rest, 3 to 5% of energy goes to breathing. When you decrease compliance, the energy demands increase dramatically, which we talked about with respiratory distress syndrome, and breathing becomes exhausting. The respiratory system adapts to meet your changing needs by changing the number of breaths per minute and the amount of air moved per breath, which almost sounds like the whole cardiovascular thing, where when you need more oxygen at the tissues, you increase the force of the contraction, so you increase the amount of blood moved with each heartbeat, and you increase the number of heartbeats per minute. So it's kind of the same thing, different test. You squish stuff and it moves. So the last thing for me on page 10 and yours might be a little different. The respiratory rate is the number of breaths per minute. I believe 16 is considered, 16 or 17 is considered average at this time, I think. So we are going to cut there. We will come back with all of the formulas. So this has been A&P 2 lecture test for video 6. Let me write that down. I got 5 written down, but I haven't written down 6 yet. Okay, so we're at video 6. Noteset pages, let's see, 5, we just did page 8, and then we did pages 8 through 10. And we're ready to start 11 with the next video. So thank you as always for tuning in. I appreciate that you all are still here and still learning. I know learning at home is not as easy as just going to school and sitting in a classroom. So I appreciate that y'all are still here. So this has been, I already said that part. Yeah, so thanks again. The education must go on. Dr. J out. Control, escape.